Friends, in this module we will discuss the domain and range of trigonometric functions. Using domain and range, we will plot their graphs and check their periodicity. Domain and range of a trigonometric function. From the definition of sine and cosine functions, we observe that they are defined for all real numbers. Further, we observe that for each real number x, minus 1 is less than equal to sine x is less than equal to 1, and minus 1 is less than equal to cos x is less than equal to 1. Thus, domain of y is equal to sine x and y is equal to cos x is the set of all real numbers, and range is the interval minus 1 to 1, that is minus 1 is less than equal to y is less than equal to 1. Since cosec x is 1 upon sin x, the domain of y is equal to cosec x is the set x such that x belongs to real numbers and x is not equal to n pi, where n belongs to z, and range is the set y such that y belongs to R and y is greater than equal to 1 or y is less than equal to minus 1. Similarly, the domain of y is equal to sec x is the set x such that x belongs to R and x is not equal to 2n plus 1 pi by 2, where n is an integer, and range is the set y such that y belongs to R, y is less than equal to minus 1 or y is greater than equal to 1. The domain of y is equal to 10x is the set x such that x belongs to R and x is not equal to 2n plus 1 pi by 2, n belonging to integers, and range is the set of all real numbers. The domain of y is equal to cot x is the set x such that x belongs to R and x should not be equal to n pi, where n belongs to z, and the range is the set of all real numbers. We have already seen that values of sin x and cos x repeat after an interval of 2 pi. Hence, values of cosec x and sec x will also repeat after an interval of 2 pi. Values of tan x will repeat after an interval of pi. Since cot x is reciprocal of tan x, its value will also repeat after an interval of pi. Table is here to show the domain and range of trigonometric functions. So, we see that for the sine function, domain is all real numbers and range is minus 1 to 1 in the closed interval. For the cosine function, domain is all real numbers and range is closed interval minus 1 to 1. For tan function, domain is all real numbers except the odd multiples of pi by 2 and range is all real numbers. For cot function, the domain is all real numbers except the integral multiple of pi and range is all real numbers. For sec function, the domain is all real numbers minus the odd multiple of pi by 2 and range is all real numbers minus the open interval minus 1 to 1. Also, for the cosec function, the domain is all real numbers minus the integral multiple of pi and range is all real numbers minus the open interval minus 1 to 1. Using this knowledge and behavior of trigonometric functions, we can sketch the graphs of these functions. The graphs of these functions are shown below. First, this is the graph or the sine function. Second, is the graph of your cos function, graph of y is equal to tan x, and graph of y is equal to cot x. This shows the graph of sec function and graph of cosec function. In example 1, we will draw the graphs of sin x, 2 sin x and half sin x on the same graph and compare. To draw the graph of y is equal to 2 sin x, we start with the graph of y is equal to sin x and multiply y coordinate of each point by 2. This has the effect of stretching the graph vertically by a factor of 2. For the graph of y is equal to half sin x, we multiply the graph of y is equal to sin x by half. This has the effect of stretching the graph vertically by a factor of half. On this graph, we can see the comparison of these three. The pink line represents the graph of the function y is equal to 2 sin x, and the blue line is simple graph of y is equal to sin x, whereas the yellow line shows the graphs of the function y is equal to half sin x. In example 2, we will show that graph of y is equal to minus cos x is reflection of the graph y is equal to cos x along the x axis. Now, we will draw the graphs of y is equal to minus cos x and y is equal to cos x on the same axis. We observe that these graphs are as follows, which here represents pink line as graph of the function minus cos x, blue line as the graph of the function y is equal to cos x, and what we observe is that one is reflection of the other in the x axis. In example 3, we will draw the graph of y is equal to cos x and y is equal to minus 3 cos x on the same graph. The graph is shown below. The pink line represents the graph of the function y is equal to minus 3 cos x, which if we compare to the blue line which represents the graph of the function y is equal to cos x, is clearly showing that the pink graph has been stretched vertically upwards. In example 4, we will compare the graphs of the curve y is equal to sin kx, where k can take different values. To see how the value of k affects the graph of y is equal to sin kx. We know that if fx is the periodic function with period lambda, then period of fx is lambda by k. Let us observe the graph of the function y is equal to sin 2x. Since the period of sin 2x is 2 pi divided by 2, which is equal to pi, the graph completes one period in the interval 0 is less than equal to x is less than equal to pi. For the graph of the function y is equal to sin of half x, the period is 2 pi divided by half, that is equal to 4 pi, and so the graph completes one period in the interval 0 is less than equal to x is less than equal to 4 pi. We see that the effect is to shrink the graph horizontally if k is greater than 1, or to stretch the graph horizontally if k is less than 1. On these three graphs, we can see in graph 1 y is equal to sin 2x, in graph 2 y is equal to sin of half x, and graph 3 shows the comparison of these two graphs. For comparison, we will draw the graphs of 4 different functions on the same sheet. The black line represents the graph of the function y is equal to a sin x. The pink line represents the graph of the function y is equal to a sin 2x. The blue line represents the graph of the function y is equal to a sine of half x, and the yellow line represents the graph of the function a sine 1 by 3 x. So, we can compare these four graphs with each other on the same graph paper. Students, in this module we have seen how to get the domain and range of trigonometric functions. Also, with the help of domain and range, the graphs of all trigonometric functions were plotted. Also, we examined the changes in the graphs of sine and cosine function when they were multiplied by a constant or an angle was multiplied by the same.